Okay, so we want to study econometrics. The first question that you want to ask is, what is econometrics? Here's a definition from our textbook. Econometrics is about how we can use theory and data from economics, business, the social sciences, along with tools from statistics to predict outcomes, answer how much type questions, and test hypotheses. So here I hope you appreciate that to conduct econometric analysis, we need to start from theory, economic theory, or theory from finance, marketing, any other disciplines. And then we gather data using tools from statistics to analyze the data. So we can use this result to predict outcomes or answer if X increase by 1 unit, how will Y respond, increase or decrease by how many units. And we can use this result to test a hypothesis. For example, in hypothesis could be X positively affect Y. Okay, we can test this. Right, let's look at it. Let's look at a simple examples. Suppose you run a business that produce and sells coffee. Is a coffee shop. And your problem is you need to make decisions on how much to spend on advertising. So you want to make an optimal decision. And certainly your goal is to make sure your advertising promotes sales to the greatest extent. Okay, to help you make an optimal decision here, you actually need to understand the demand for your product, for your coffees, which we call this demand function. It is the relationship between quantity demanded and price, income, advertising, and all the other factors. So here's where you can use your econometrics to help you make informed decisions. And we can do this step by step. Step one, so we start with economic models. Okay. So economic theory suggests that the quantity of demand is a function or depends on coffee price, consumer incomes, advertising expenditures, and the other factors. We can write in this equation, Q is quantity of demand, number of cups of coffee your coffee shop will sell in a week. Say P is the price of coffee, Y is income. Say a representative consumer's income, $1,000 per week. Advertising is A is advertising expenditure. E, here we use E to capture everything else. And F here is a function form, is a very general function form. It only says that the quantity demand depends on these four factors. Okay, that's the economic models. And from economic theory and intuitions, we can hypothesize that, okay, price will negatively affect quantity. Higher prices, lower demand. Everything else being equal. Ceteris paribus. We call this lower demand. Okay, this is where you learn this lower demand from first year principal economics B1003. Also, it's likely that income positively affect the quantity of demand. Higher income, higher demand. And also advertising, we can hypothesize that advertising will positively affect quantity of demand. The more you advertise, it's likely that the consumer will like your coffee more. Okay, we have economic model. This economic model actually help us establish in econometric models. So from the economic models, we can set up the corresponding econometric models. For example, we can set up a linear econometric models. We say that quantity demand is equal to beta 0 plus beta 1 times the price plus beta 2 times the income plus beta 3 times advertising expenditure. E plus an error term. E is the error terms. This is a linear econometric model. Alternatively, we can set up a what is called log linear econometric models. Log Q is equal to beta 0 plus beta 1 times log P plus beta 2 times log Y plus beta 3 times log A, which is advertising expenditure in natural logarithm forms, plus error terms. So here, for both either econometric models, the betas, they are unknown parameters, which we intend to estimate. For example, we might want to find out beta 3 is positive or negative. If beta 3 is positive, then we can say that advertising promotes or positively affect the quantity demand. If it's negative, then negative affect quantity demand. Okay, so the betas, they are unknown parameters we want to estimate from data. To do so, we need data. So step 3, let's go to collect data. So we need to have data of quantity of demanded, price, income, advertising expenditure in order for us to estimate the data. Suppose we collect data like this. Say these are coffee shop. Okay. For example, the first coffee shop charge a price for coffee $4.50. The consumers who visit the coffee shop has an average income of $1,000 per week, and this coffee shop spend $200 in advertising and sell 200 cups of coffee. First coffee shop, second coffee shop, third coffee shop, fourth coffee shop, so on and so forth. Then we have this data, a set of data set. From here, we can, using econometric methods, to estimate the betas. What is beta 0? What is beta 1, beta 2, beta 3? So step 4, estimate the econometric model using a desirable methods of statistical analysis. We will go through these different methods as we move forward. And in principle, we can do this exercise manually by hand. However, that will be very time consuming. Okay, so we use statistical software to implement this estimation. Typically, we are going to use what is called ordinary least square estimators in the estimation. For example, for our case here, and we are going to use R package, which is freely available. All right, that's step 4. Step 5, then you collect data, you estimate the model, econometric models. Then now you need to check whether the estimation is right or not, whether you get things right. For example, you want to use model diagnostics to check the validity of assumptions. You need to care about potential issues like endogeneity, multicollinearity, heteroscedasticity, so on and so forth. And if everything is fine, then you can conduct hypothesis testing. You can test whether advertising promotes positively affect the quantity demand for your coffee shop, for your coffee or not. Okay, so you see that we have a number of jargons here. If these jargons are new to you, don't be scared at the moment. We will go through them step by step as we move forward. Okay. Then step 6, then you can use the estimation results in your business decision making. For example, suppose that you estimate the demand function to be this. And particularly, we want this is 0.002 is the estimate of beta 3. Okay. So it is positive. Then this 0.002 means that an increase in the advertising expenditure by $1 will increase the demand for your coffee by 0.002 cups. And this piece of information should help you to make an informed decision regarding how much you want to spend on advertising for your business. Okay, this is a simple example. I hope it illustrates to you what econometrics is and how we can use it. And here, I hope you appreciate that there are two important components here. First is theory, economic theories, or theories from other disciplines like finance, marketing, management, so on and so forth. Second component is data. Theory, economic theories. In general, economic theories make statements, hypotheses that are mostly qualitative in nature. For example, for the demand functions, we see that the price goes up, demand goes down, quantity of demand goes down. So price negatively affect the quantity of demand, and this is called lower demand. However, this demand theory itself does not provide any numerical measure of the relationship between price and quantity demand. It does not tell you by how much the quantity will go up or down as a result of a certain change in the price of goods. Say price goes up by $1, while the quantity demand goes down by 5 cups of coffee or 3 cups of coffee. So to get this numerical estimate, we need to use econometric methods. In our real life, we have scarce resources, so we often need to make different choices subject to our resource constraints. For example, we may be faced with questions like this: how much should a household spend for consumption? How much should I spend for dinner? Where should I go for dinner? How much should a country produce to fit its citizens? And many other different choices we make in our daily life. So for empirical justification of these choices, like our example, the coffee shop examples, we require data for us to estimate the numerical impact of X on Y, impact of advertising on quantity demand. So how can data help us to understand this world of choice? To answer this question, we require the techniques of econometrics. Econometrics is a multidisciplinary subject used for empirical analysis of big or small data coming from a wide range of subject areas like economics, finance, marketing, management, accounting, sociology, legal study, geography, environment, medical, and engineering sciences. So it provides different ways of analyzing relationship between variables. Econometric techniques are quite popular among researchers and practitioners for data analysis. Right. Researchers are frequently interested in empirical verification of economic theories or theories from other disciplines. And to do so, then we use econometric methods to verify these economic theories. And our textbook provides a definition, a nice definition for econometrics, which we just went through it in slide 2. In addition, there are other alternate definitions in econometrics literature. Let's quickly go through some of them. Samuelson, Koopmans, and Stones in the 1950s defined econometrics as econometrics might be defined as the quantitative analysis of actual economic phenomena based on the current development of theory and observation. related by appropriate methods of inference, which comes from statistics. Goldberg, in his econometric theories book, defined econometrics might be defined as the social science in which the tools of economic theories, mathematics, statistical inference are applied to the analysis of economic phenomena. In statistical methods of econometrics, it is Maningvold said the art of econometrician consists in finding the set of assumptions that are both sufficiently specific and sufficiently realistic to allow him to take the best possible advantage of data available to him. Tintner, in his methodology of mathematical economics and econometrics, said, econometrics, the result of certain outlook on the role of economics, consists of the application of mathematical statistics to economic data to lend empirical support to the models constructed by mathematical economics and to obtain empirical results. Okay, Tell, in his principles of econometrics, econometrics is concerned with empirical determination of economics laws. Okay, all these definitions they clarify the role of econometrics for data analysis in general. In the context of economics, we investigate economic problems empirically, utilizing the techniques of econometrics. Therefore, econometrics analysis consists of these three things. First, quantitative formulation and investigation of the relationship between variables, between the quantity of the number of cups of coffee that my shop can sell and my advertising expenditure. Then we want to numerically determine the unknown parameters and interpret the estimation correctly. We can use this estimation result to test the hypothesis of economic theory or finance theories or theories from other disciplines. So in doing econometric analysis, an important part is to formulate economic hypothesis into econometrically testable hypothesis. This will include estimation of relationship between different variables, testing economic theories and hypotheses. Forecasting, we can use the result to do forecasting or look at the causation of economic variables. We can evaluate implement government or business policies. In doing so, we require data. Data plays a crucial role in econometric analysis. Without data, we cannot cook up the research. So we require data for empirical estimation of the theories. So how do we collect data? You need to ask now, where do the data come from? So generally, we can gather data from in three ways. First, experimentation. We conduct experiment, collect data from the experiments. Second, we can collect data from quasi-experiments. Thirdly, more frequently, data are observational. They are collected from real life, for example, like from survey, or they are from administrative records. Let's look at experimental data first. So here, we want to design and conduct an experiment, collect data from the experiment. This data collection method is frequently employed in sciences. For example, like in health, we want to test whether a new drug is effective or not. We can conduct clinical trials, which is one type of experiments. It is more difficult and therefore less utilized in social sciences. For example, we want to look at whether the Reserve Bank increase the interest rate, decrease the inflation rate or not. And we cannot conduct experiment on this. We cannot ask Reserve Bank to do experiment on this, or it's too costly to do so. Okay, experiment, a key feature of it is that they are implemented in a controlled environment. That is, researchers can control many other factors. I want to look at the impact of X, how X affects Y. X is treatment variables, Y is outcome variables. Certainly, there are other possible factors that influence Y, but in experiments, I can control all these other factors. Let's look at examples. Suppose my aim is to investigate how fertilizers and the pesticides affect the yield of wheat. So the X will be the amount of fertilizers and pesticides applied. Y, the outcome variable, will be the yield of wheat, how many kilograms of wheat we harvest from the land. Okay, so to investigate these problems, we can design experiments. Suppose I'm going to choose in similar plots of lines, and in my drawing here in 7, I'm going to choose 7 plots of lines. And ideally, these lines should be identical, but certainly in reality, we cannot have identical. So we need to have similar. So these lines are of similar characteristics. We know that different lines, say one line may be more fertile than another. So everything else being equal, we are going to harvest more wheat from this line than the other line. So in such cases, the land characteristics plays a role in the yield of wheat. So we need control for these factors. So we want to choose similar plots of lines. Then we choose a variety of wheat. Again, everything else being equal. Different variety of wheat, they have different yields. Okay, wheat characteristics. So we control the characteristic of wheat by choosing a variety, a particular variety. Then we set different levels of fertilizers and pesticides. These are different treatment. These are treatment. Okay. Randomly applied these different levels of fertilizers and pesticides to these 7 plots of lines. For example, land 1 might be 0, no pesticides, no fertilizers. Land 2 could be 0.5, 1, 0.1, 1.5, 2, 2.5, so on and so forth. Okay. Then in the harvest season, we can harvest the waste from all these lines. We can measure how many kilograms waste we harvest from the line. Suppose this is 100 kilogram. This is 105, 120, 102, 130, 150, 120. Okay. Then these are the data we collected, and we observe that there's a variation of the yields, kilograms of waste we harvest from lines. Also, there's a corresponding variation in the level of fertilizer and the pesticides we apply. And these two variations are, so the variation of the yields are due to the variation of the fertilizer and pesticides. we can say it clear here because we control all the other factors, like the land characteristics, the width characteristics. They are all controlled. Okay, this is an example of collecting data from experiments. Sometimes a key feature of this experiment is the treatment, the different levels of fertilizer and the pesticides. They are randomly assigned to the different plots of lands. Okay, this random assignment is a key feature of this experiment. However, it may not be feasible in realities. Instead, assignment of treatment is based on another criterion. It's not randomly done, but based on another criterion. Data collected in such a way, we call it quasi-experimental data. Let's look at examples. Card and Kruger. They studied the effect of the increase in New Jersey's minimum wage in 1992 on the number of people employed in fast food restaurants. So now observe here that this minimum wage policy is implemented in New Jersey, but not in other states. So this assignment of this treatment, this minimum wage policy, is not random. It's not random, okay? So here, the treatment group is fast food restaurants in New Jersey. Control group is a fast food restaurants in eastern Pennsylvania, so where there's no minimum wage policies. And the data that they collected is called quasi-experimental data. More frequently, data are non-experimental. In social sciences, including economics, finance, and marketing, data are frequently collected in real life, not from experiment. These data are called observational data. For example, I can design a survey. I can survey people, collect data from survey. Or I can go to administrative records to get the data. For example, like the records of imports and exports of Australia in year 2023. We can get this data from the customs. Okay. So these data are called observational data. One thing here is that observation data, the data we observe in real life, are usually the outcome of many different factors, confounding factors. So when we conduct econometric analysis using this observation data, we need to be, in a sense, more careful than using experimental data. Here are some sources where you can find the data in Australia. For example, Australian Bureau of Statistics, the website abs.gov.au, and also statistical bureaus of other countries, US, Japan, China, European Union. Also, Reserve Bank, the central bank in Australia, they provide data in their websites as well. Cross-country data. For cross-country data, one good source is World Bank Development Indicators. It has country-level data of many different variables like GDP, interest rate, population, foreign investment, so on and so forth. Nowadays, technology has allowed us to collect data from real life in a massive scale, and we have what is called big data. For example, an online shopping platform such as Amazon has a large amount of data of daily transactions that clients made in this platform. Google or social media platforms such as Facebook, they have mass data of the users, what the users do in the social media platform. What does clients Google, in the Google search engines. All this data is massive. So researchers have established data warehouse to process, capture, store, and maintain these large data sets. And methods are developed to extract useful decision-making information from this large data set, data mining. So researchers mine data from the warehouse, convert it into useful information by using statistics, mathematics, econometrics, and computer science. Okay, that's how we can gather data from experiment, quasi-experiment, real life. Data, economic data, often come in a variety of flavors. For example, we have different level aggregations. The data of quantity of demand for coffee of each coffee shop, price, consumer income, representative consumer incomes, and advertising expenditure. These data are at the coffee shop level, so it's individual unit level. So these data are disaggregated microdata. Alternatively, in contrast, we can have what is called macrodata, aggregated data. For example, like GDP of Australia from 1950 to 2024. Okay, this annual GDP is aggregate data. Data variables in data can be flow variable or stock variable. A flow, an example, would be the cups of coffee that Sun's Cafe sold in week 1 of 2024. So this is a flow. In contrast, a stock variable could be like this. The cups of coffee Sun's Cafe has sold since its operation on 1st of January 2019. So this is all the stock of cups of coffee that I sold. Okay. Variables in data could be either quantitative or qualitative. Okay. For example, the sales revenue of my coffee shop, which is a variable, is a quantitative variable. It takes value of continuous variables. Say the sales in a week will be $1,000, $1,000.01, so on and so forth. In contrast, whether Sun's Cafe advertise, this variable is qualitative. Okay, it only takes two values: 0, no advertisement; 1, yes, advertisement. Okay, this is what we call dummy variables. Okay, data have different types. For example, one type could be time series data. It is a series of observations over time. The key feature of time series data is that the same economic quantity is recorded at a regular time interval in a year, annually, monthly, quarterly, or half yearly. An example would be real US GDP over 1994 to 2014. Like this one, we can draw the trend of this, the time plot of annual GDP of real 2009 dollars of the US. Data can be cross-sectional. What do we mean by cross-sectional? These are collection of sample units in a particular time period. It's a cross-section of time period. For example, race, education, sex, and the wage of individual employees of a firm in year 2013. Cross-sectional data. Here, the table here is an example of cross-sectional data from current population surveys in March 2013. It says there are 9 individuals in that particular time period. For the first individuals, the race of this person is white. Education level, he has an associate degree he's a male, gender, and his wage is $10 per hour. So of these 1, 2, 3, 4 of these 4 variables, the first 3 variables, they are qualitative, which is categorical. Race, you have different category. Education, different category. Gender, male, female, non-binary. In contrast, wage is quantitative variable. It's continuous. For this particular person, it's $10 per hour. So on and so forth for the other individuals. Data could be panel or longitudinal. These are observations on individual micro units that are flowed over time. So we have 1 unit, have data 1 unit across different time periods. For example, data of sales revenue of 2 firms over the periods from 1990 to 1997. So this table is an example of panel data of 2 rice farms. Farm 1, Farm 2, from year 1990, 91, 92 to 97. Similar from Farm 2 from 1990 to 1997. So this is what we call panel data. In addition, this particular example, we call this balanced panel data because of these 2 forms, they appear in all the same years. If instead we have, let's say for Farm 1, let's get rid of this observation. For Farm 1, we don't observe is 1997 data. Now we have different time lengths for Farm 1 and Farm 2. We call this unbalanced panel data. All right, that's panel data or longitudinal data. Sometimes cross-sectional data of different time periods, they are pooled together, resulting in what we call repeated cross-sectional data. So you want to know the difference between this repeated cross-sectional data and longitudinal data. So in panel data or longitudinal data, units of measurement, the forms, are the same across time. In contrast, repeated cross-section units are different across time. Okay, that's data, a crucial component for our econometric analysis. Econometric is a tool, it's a research tool we can use to conduct empirical research. In doing empirical research, there's an orderly pattern which generally we follow, like this. So first, we start from economic theory or theory from other disciplines, finance, marketing, management, so on and so forth. This theory gives us a way of thinking about the problems. Then we start from this working economic model. Follow the economic model, we set up an econometric models, which is what we can use data to estimate. Then we obtain sample data and choose an appropriate econometric methods. Then estimate the unknown parameters, the betas, in our examples previously, using a particular statistical package. And then we check all our estimations are correct. For example, by using diagnostic tests, then perform hypothesis tests. Then, if everything works out well, then we can use this estimation for our purpose. So the economic consequences and implications of the empirical results, we can analyze them, evaluate them. Okay, so you finish our research, then you need to write up as a research paper or report. Here are the general format we have for a research paper. You need to have first component we need to have is statement of main research topic. I'm going to look at the research. The research topic is whether by how much the advertising affect the quantity of demand for my coffee. Then I need to review the existing studies on this area, review literature related to this research problem. Then I developed specific research question or hypothesis. This is where you need to use economic theory or theories from another disciplines to guide your research. And from there, you also set up the econometric models. Then talk about data, how you collect data, how you manipulate the data, and talk about the methods you utilize, detail the methods that you utilize for the estimation. Then you discuss the empirical data analysis, estimation tests, interpretation of the results, and you also want to be clear about the limitations of the studies and the possible future extensions. Then you can conclude the research. And you also want to acknowledge any people's helps and your studies, and make sure you have a list of references. Okay, this is a typical format for writing a research papers. Okay, in econometric analysis, in principle, we can do it by hand, but in practice, that will kill us. So we need to utilize statistical software to implement these estimations. There are different econometric packages in the market here in real life. We are going to use R. It is freely available online, and it is extensively used in mathematics, statistics, social science, health science, environment, engineering science. And you can find R package in their website, or you can Google it. The interface of R is, I've called it very primitive. It's not user-friendly. So on top of R, we're going to use R Studio. So it is a user-friendly, integrated development environment for R. So you can find, it's also free. You can find it from this website, or you can Google it. So we are going to use R Studio, this development environment, to use R. Okay. Other alternative econometric packages include Stata. So actually, in my own research, I use Stata frequently. Also, Rats, Cats, Shazams, eViews. The key thing is that these packages, they are not free. They are commercial package. They might have student versions. If you wish to purchase them, you can. But for the subject purpose, we are going to use the free R and R Studios. Okay, this is all I want to introduce to you on the econometrics subject that we will do in the next few weeks. And in the separate videos, I'll show you how to install R and R Studios in your laptop, for example, and I'll go through some basics of R programming.